All right. So let's talk about function notation next. And function notation is basically what we're going to use to decide if something is a function. We can write it as f of x. We read this f of x, a function of x. Y is a function of x. Y is equal to a function of x. Okay, f of x is how we read that. It's not f times x. And the advantage to this is I could write this as y equals 5x plus 7. But as soon as I plug in a number for x, let's say I plug in 0, I would get y equals 5 times 0 plus 7, y equals 7. Once I get y, once I plug in a value for x and then evaluate my y, my x went away. The advantage to having function notation is you're going to say f of 2 is equal to 5 times 2 plus 7, and that will allow you to know what your original x value was, because you're going to evaluate this the same way. You're going to have 10 plus 7, that's 17. That ordered pair is 217. The x was 2, and you see that from the function notation, and the y is 17. So it translates into an ordered pair, but this is just another way of writing it. So we have f of 10 means I'm going to replace 10 for x, and I'm going to evaluate. So I have 10 times 5 is 50, plus 7 is 57. Who can tell me what the ordered pair is? Yes, so all the function notation is saying is f of x is equal to, that f of x replaced the y, and then it's telling me plug in 10 into my function for x and find out what the y is. So the ordered pair here would be x was 10 and y is 57. Yes, so what I'm plugging into x is the thing that's inside the parentheses. It's what's replacing the x. And so we just take the function 5x plus 7. I'm going to replace the x with 100, and then I get 500 plus 7. I'm just evaluating. I'm plugging in a value for x, and then I'm simplifying. That's all we're doing, okay? And so if the input is negative 10, that's our x, we're just going to write 5 times negative 10 plus 7. And we're going to simplify that down. Because this number here was negative 10, it's getting plugged in for x. So you see here we have f of x equals 5x plus 7. When we replace that x with negative 10, we're going to replace wherever we see an x, we're going to plug that number in. So we would get negative 50 plus 7. And can anyone tell me what that is? Negative 50 plus 7? Yes, negative 43. Same thing here. I don't actually have a number. I can put anything in there. So this is 5 money signs plus 7. I can't simplify that any further because I don't have, number sign is not a value. But it's just saying whatever is in there gets plugged in for x. Same thing here. I'm going to do x plus 3. So I have 5 times x plus 3 plus 7. Now I could simplify that a little further by using my, what do we call that? Yes, distributive property, 5x plus 15 plus 7. And could that be simplified any further? What would you get? 5x plus 22. Now, I didn't have an x, but this is just x plus 3 more, and that's what it would simplify to. Okay? Do you have a question? Yeah? Oh, yes, an ordered pair. Okay. You don't. I was just trying to indicate what it would look like, what the x and what the y was. So if we wanted to say, like for here, this one would be 100, 507. This one would be negative 10, negative 43. This one would be money sign, 5 money sign plus 7, but that doesn't really make sense on a graph. How are you going to graph that? It's just really about the inputs is that number that's replacing X or the symbol, and then the output is whatever you would get once you plug that number or symbol in. Okay? So it's just showing you that this is X and this is Y. Okay? But this one doesn't really make any sense. It's just showing you, you could put anything as the input, and that's just what's replacing the X. Okay? Let's try these other two. Let's have you try them, and then we will share out on those. So here you have G of -1 equals, what did you guys do for this one? Did you plug in the -1 for X? And then what'd you get? 3 minus 8, which is -5. And if you wanted to write it as an ordered pair, it means -1, 5. Good. Oh, yeah, you're right. Okay, what about this one? So we're going to go G of X minus 4, and that's going to be -3 times X minus 4, because that's what's substituting in for X, minus 8. And then here, what did you do to simplify? -3, yes, plus 12 minus 8, which is -3x plus 4. Any questions on that? Yes? -3, oh, sorry. Well, this is right. Oh, I see what you're saying. Is an ordered pair. I wouldn't really write it as an ordered pair. Yeah. Okay, so for the next one, we're going to answer the following questions about the table. Let's look at the table and determine, is it a function? What do you guys think? Is it a function? Yes, it is a function. Is it okay that the 40s are repeating? Why is it okay that they're repeating? Because they're in the range, sorry, not the domain. Okay, state the domain. What's the domain? Okay, and what is the range? And I'm just going to put this in order. So 25, and since 40 is repeating, 40 is the same number, so I'm not going to list it twice. And that's another way of seeing that we have fewer elements in the range than we do in the domain. Okay, and then f of 0. I don't have an equation, but I can use the table. So this is telling me that x is 0. And what's the corresponding y value? -10. And that comes from the table 0, -10. What about f of 40? What's f of 40 equal to? 0. And notice that the 40 represents the x. So I'm going to x is 40 to get y is equal to 0. And that's why this is equal to 0. What's f of 100? It's kind of a trick question, right? It actually is not in my table. It's not part of the function. So it doesn't exist. Does not exist would be one way of answering this. Or you could also say undefined. Because it isn't part of the table. X equals 100 is not part of the domain. So we don't have an answer for that. If we had an equation, we could plug it in, but we don't have an equation. This is literally a relation because we have 1, 2, 3, 4, 5 ordered pairs. On a graph, this would be 5 distinct points, and that's all it would be. It wouldn't be like a line or curve or any of that. Okay? Any other questions on this page?